one-step equations. We're going to isolate the variable, and we're going to use addition, subtraction properties, and or multiplication, division properties to isolate the variable. Looking at number 1, we're going to copy this equation into algebraic solution exactly the way you see it. X plus 4 equals 5. Draw your line down the equal sign, and our goal is to isolate the x, which is our variable. And I'm going to highlight that so that it reminds me that I need to leave that by itself. I know in front of this 4 that I'm trying to move over to the other side is a positive sign, so I will simply just subtract the 4 from this side. Once I've subtracted the 4 from the left side, I must do the same thing to the right side. So I'll subtract 4 from the right. Now I'm able to cancel my 4 because 4 minus 4 equals 0, and I'm left with my x. So I'll just simply write x right here. And 5 minus 4 equals 1. That's my algebraic solution. We're going to use our calculator to do the graphic solution and the table. I'll get my calculator, turn it on, and go to y equals. The left side of the equation was x plus 4, and the right side of the equation was 5. Once I put that into y equals, I'm able to graph it by simply pushing the graph button. And I get a graph that looks like this. Now keep in mind we're looking for the solution where the red line and the blue line intersect. So in this example, they intersect at this point. If you see, if we were to graph that point, it would be 1, 5. So I'm going to write 1, 5. And if you pay attention to the algebraic solution, we were looking for x. So the one that we're concerned with in the graph is my x value, which happens to be 1. Going back to the calculator, we simply push second graph to get our table, and we're looking for our solution. Again, we're looking for the blue and the red, where they're the same, where they intersect. That's my y1 and y2. And if I scroll just down 1, I know that they intersect at 1 because my blue is equal to 5 and my red is equal to 5. That's where they intersect on the table. So as I write my table down on my paper, I'll take my highlighter and I'll highlight the 1 simply because y1 and y2 are both 5s. They're equal. Okay, so we've gone over how to do it algebraically, and we've gone over how to use a calculator with the graph and table. So we're going to check our answer because all 3 ways have shown and told us that our answer is 1. So we'll take our x, and I'll take my highlighter to show x is 1. X is 1. And then x is 1 right here. Since x is 1, I'm going to place it where x is, just to check my work, make sure we did everything correctly. So I'll take this same equation and I'll rewrite it right there. I'll rewrite x plus 4 equals 5. And because I was using green for my x, I'm going to substitute this number 1 into my x. And now I'm going to put 1 plus 4 equals 5. Now where did that 1 come from? That's our solution that we're checking to see if it's correct. 1 plus 4 is 5. And 5 does happen to equal 5. Therefore, our answer is correct. Number 2. We have negative 9 equals x minus 4. We're going to begin with rewriting this in the algebraic solution column. So I will rewrite negative 9 equals x minus 4. And I will draw my line down the equal sign. I'm going to grab my highlighter because it's easy for me to see. If I highlight my x, I know that x has to be by itself. Sometimes x is on the left side, sometimes x is on the right. In this case, x is on the right. In my first example, x was on the left. Keep in mind, when we're trying to get rid of a value from a side, we always need to use the inverse. If it's a negative 4, we know that the opposite of a negative is a positive. So we're going to add 4 to this side, our right side. Well, if I added 4 to the right, I have to add 4 to the left. What you do to one side, you must do to the other. Now I can cancel my negative 4 because a negative 4 plus 4 is 0. And I simply write my x down below. We have a negative 9 plus 4. When we add those two values together, we take the sign of the larger number, which happens to be negative 9, and then we subtract. So 9 minus 4 is 5. So x is equal to negative 5. Now we'll take our calculator and we'll work on the graphic solution and the table. When we use our calculator, just a reminder, the left side is y1 and the right side is y2. So let's pull the calculator over. I'm going to clear it. And go to my y equals. When I go to my y equals, the left side is negative 9 and my right side is x minus 4. I'm going to graph it, and remember we're looking for the intersection of the red and the blue line, and we know that they intersect at this point right here. So our graph looks like this, and it intersects at negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at negative 5, 9 is where our red and our blue line intersect. So far we're doing so good. We have two that are correct, where our x is equal to negative 5 and our x is equal to negative 5. Now for the third method, our table. We'll go to our calculator, and we already have our y1 and y2 in our calculator. So all we have to do is push second, graph, go to the table, and we're looking for where y1 and y2 are equal. Negative 9, negative 4, no. Negative 9, negative 2, no. Since we kind of know that it's going to be negative 5, and we're hoping that it's negative 5, we're going to scroll up. And yes, it is. Negative 5 is when x is equal to negative 5, y1 and y2 are both equal to negative 9. Since y1 and y2 are both equal, negative 5 is our answer. we have our table right here. I'm going to take my highlighter and I'm going to highlight where they're equal to. So I have -5, -9, -9. Keep in mind that whenever you look at your calculator, do not think that this is always your answer. It could possibly be your answer, but the reason it says -8 is because I have -8 highlighted on my calculator. It doesn't mean that that's the answer. Okay, we're always looking for where y1 and y2 are equal, and that happens to be at -5. Now we're going to check our solution, and we're going to take the original problem and we're going to copy it into solution check. So I'm going to write -9 equals x minus 4, and I'm going to draw my line down, the equal sign. I'm going to take my highlighter, same color that I've used. X is equal to -5, x is equal to -5, x is equal to -5. So since x is equal to -5, that's where I'm going to input my number just to check to see if it's correct. So -9 equals -5 minus 4. We have -9 equals, and we have two numbers that we're adding together with the same sign, so we simply keep the sign and we add the numbers. So -9 does equal -9, and we've done it correctly. The first one was an example of subtracting a value from both sides where the x is on the left side. So we subtracted. The second one was an example of where we added a value to both sides with the x being on the right side. So this is with addition. Now we'll look at two examples dealing with multiplication and division. Number 3, I'm going to take my equation and copy it into algebraic solution. So we're going to write 2x equals 10, and I'm going to draw my line down the equal sign. I know that I need to isolate my variable, which happens to be x in this example, and so I'm going to highlight it to remind myself that I need to keep that where it is. I need to get rid of all other values. The value that's in my way at the moment is number 2. Number 2 is being multiplied by the x, and so I'm going to divide 2 on both sides. 2 divided by 2 is 1, which is what I want because there's always an understood 1 value in front of the x, and I'll just simply write my x down below and calculate the right side. The right side is 10 divided by 2, which gives me 5. That is using my algebraic solution. Okay, so now it's calculator time. I know whenever I use my calculator, the left side is y1 and the right side is y2. So when I bring over my calculator, I'm going to type in my y1 as 2x, and I'm going to type in my y2 as 10. When I graph it, I'll get 2 lines. And remember, when we get the 2 lines, we're looking for the intersection of the 2. That's our solution. Not our y value, but our x value, because that's our variable that we're looking for, our x variable. We have the blue line and the red line's not graphing. Oh, sorry. Let's see. 2x and 10. Blue line, red line. Notice the intersection. That's the coordinate point that we need. So we're going to look. It is at 1, 2, 3, 4, 5. and up to 10. So it's 5, comma 10. That's the coordinate point where the blue and the red line intersect. Now that we've got the graph down, we're going to look for the table. Using my calculator, I'm going to hit second graph. And I'm looking for where y1 and y2 are equal. I see it right here. 5 is x when y1 and y2 are both equal to 10. So I'll write my table on my paper, and I'll take my highlighter and I'll highlight 5 when y1 and y2 are equal. Please remember that this is not your answer, or not always, because I had -2 highlighted. That's the only reason that -2 is right there, not because it's your answer. Okay. I do know that 5 is my answer because I highlighted where y1 and y2 are equal, which is 10. Now it's time to check my work. I'm going to copy the original one into solution check. 2x equals 10. I'm going to draw my line down the equal. And I'm going to take my highlighter and I'm going to highlight my x, my answer. I know x is equal to 5 when I do it algebraically. I know x is equal to 5 when I do it on the graph. And I know x is equal to 5 when I do it on the table. So I'm just going to put 5 into x to see if I did it correctly. So I'm going to write 2 times 5 equals 10. If 2 times 5 is equal to 10 and 10 is equal to 10, therefore we did it correctly. We got the right answer. Using 3 different methods. We used the algebraic solution, the graphic solution, and the table. Number 4. We have x divided by 2 is equal to 5. We're going to copy that into the algebraic solution. X divided by 2 is equal to 5. And now we're going to solve for x. We need to isolate the variable. I'm going to highlight the variable so that it reminds me that I need to leave that variable alone. I need to get rid of all other values except for that variable. Now, what's in my way? A number 2 is in my way, and it's being, or the x is being divided by 2. I know that the opposite of division, or the inverse operation, is multiplication. So I will multiply 2 on the left side, and what I do to one side, I must do to the other. So I'm going to multiply 2 on the right side. Now, if you remember, a whole number can always be put over 1. When we multiply straight across, we get 2x divided by 2. Or you can think of it as 2 divided by 2. When we have 2 divided by 2x, you know that 2 divided by 2 is 1, and that's what we want. It's an understood 1 in front of your x. And so we get x is equal to 10. Now we're going to do it on the calculator for our graphic solution and our table. Remember that the left side is y1 and the right side is y2 when we put it into our calculator. y1, to input a fraction, I'm going to push alpha y equals, and on top in the numerator we'll be an x, and in the denominator will be a 2. y2 is simply 5, and now I can just graph it. I'm looking for the intersection between the blue and the red lines. So right here, we see that the intersection is at 10, 1, 2, 3, 4, 5, 10, comma 5. So I'm going to plot the point, and I'm going to write out my coordinate point, 10, comma 5. Okay. Now we're going to do the table. Second graph, and I need to go down to 10 because I kind of think that that might be the right answer. This is the third method that we've used, or that we're going to use. And yes, 10 is x when y1 and y2 are both equal to 5. So I'll write my table down and I'll highlight it. X is 10 when y1 and y2 are both equal to 5. Okay, so now it's time to check my work. I'm going to take the original problem and I'm going to write it into solution check. X plus 2 is equal to 5. And I'm going to use my highlighter to remind me of what my answer or my solutions were with all three methods. My first method, the algebraic solution, I got 10. The second method with graphic solution, I got 10 for my x value. And my third method with the table, I got 10. So I'm going to take my answers that I got and place it where x is to check to see if I got the correct answer. So I'm going to write 10 where x was over 2 is equal to 5. 10 divided by 2 is equal to 5, and 5 is equal to 5. Therefore, we did it correctly.